Hello everyone, welcome to another video session class. So in today's class we will study about reactions and medicinal uses of indole. So indole, we know it is a fused ring structure and it is a fusion between one benzene ring and pyrrole ring. Okay, so two rings are attached, one will be benzene ring and one will be pyrrole ring. So we have already seen the structure. So let us just start the reactions of indole. Okay, so first reactions of indole. So you see, this is the structure of indole. One ring is benzene ring and this ring is pyrrole ring, correct? So first, electrophilic addition to nitrogen. As there is one nitrogen, so there are lone pair of electrons present in this nitrogen, so there may be chances of electrophilic addition to nitrogen. Okay, that means because of electron there is electrophilic addition to nitrogen. So indoles like pyrrole, so I have already mentioned that indole is fusion between benzene and pyrrole. So like pyrrole are very weak bases. Okay, so if you just react with one hydrochloric acid, okay, or hydrochloric acid, that means a basicity property, that means acid will add to this nitrogen, H plus will add to this nitrogen. So you just see it will form 1H indolium cation. Okay, so that may be the hydrogen may be displaced in the pyrrole ring, so it may give 3H indole cation. That means this hydrogen will move to this position and this double bond will move to this position, so it will form 3H indolium cation, which is more stable. Or it may, in the second position, it may shift. So this red hydrogen may shift to second position by shifting this bond here, okay, by breaking this benzene ring here. So if there is breaking of benzene ring, that means there is breaking of aromaticity, so it is less stable. Okay, so it may also form 2H indolium cation. So out of this one, 3H is stable because it is not interacting with this benzene ring or aromatic character of this benzene ring. Next, another, it is methylation or alkylation. Okay, so methyl iodide may react. So this methyl group, CH3 plus group, may attack this electron present in the nitrogen to form 1 2 3 3 tetramethyl 3H indolium cation, okay, or indolium salt. Okay, so here you see iodide salt. So here methyl group 1 methyl group, 2 methyl group, 3 methyl group and 4 methyl group. So in total 4 methyl group may attach to this indole nucleus, okay, or the pyrrole nucleus present in the indole. Next, electrophilic aromatic substitution. So you will get various electrophilic aromatic substitution reaction in this indole. So position which may prone to attack are C2 and C3. That means this one is first position, second and third. So this is C3, that means this position, if there is attack in this position, so this resonance will possible and ultimately this is stable. So that's why this third position is favored. But here you see, if attack occurs at second position, so ultimately this positive sign generate will affect the benzene ring or aromaticity of the benzene ring, so which is less stable. So disturb aromaticity of benzene ring and which is less favorable. So I already mentioned, if aromaticity is disturbed, aromaticity of benzene ring is disturbed, which will be less favorable, okay, for the reaction. So mainly the third position reaction occurs. Okay, so another type of electrophilic aromatics. So let us see the electrophilic aromatic substitution reaction of this indole. So first reaction is nitration. So common nitrating agent cause acid catalyzed polymerization, high reactivity of indole. So indole can be nitrated using benzoyl nitrate as a non-acidic nitrating agent. So mainly this benzoyl nitrate, so this is the benzoyl nitrate, is mainly used as non-acidic nitrating agent. So you are getting this product, okay, NO2. So here you see common nitrogen agent called acid class polymerization, so high reactivity of indole, that will cause high reactivity. So ultimately we are going to, that's why we are going to use non-acidic nitrating agent like benzoyl nitrate. Okay, so this is the condition for reaction 0 degree. So ultimately after reaction at the third position, I already mentioned that third position is favorable because it is not affecting, attack at the third position is not affecting the aromaticity of this benzene ring. So it is forming 3-nitro 1H indole. Okay, so next sulfonation. So you see using the pyridine sulfur trioxide complex in hot pyridine. So this is the sulfonating agent, pyridine sulfur trioxide in pyridine. So ultimately at third position sulfonyl group will be, or sulfonic acid group will be attached. So 1H indole 3 sulfonic acid will form. So halogenation, for example iodination in dimethyl formamide, DMF is dimethyl formamide at in the presence of potassium hydroxide at room temperature, RT is room temperature. So it will attack the third position, 1 2 3 third position. So same for bromine, here also bromination, another type of halogenation reaction. So in presence of pyridine 0 degree Celsius, so attack will take place third position to form 3 bromo 1H indole, and here it is 3 iodo 1H indole. Okay, next reaction, another electrophilic aromatic substitution reaction, that is acylation or acetylation. Acetylation in the presence of sodium acetate afford N-acetyl indole. Indole reacts with acetic anhydride, gives 1,3 diacetyl indole predominantly, which upon hydrolysis, HL is hydrolysis with aqueous sodium hydroxide at room temperature gives 3-acetyl indole. So you just see N-acetyl in presence of acetic anhydride. So Ac2O is acetic anhydride, so it will give 1,3 diacetyl indole. So this is 1,3 or N3, you can say 1,3 means 1 is N position, so either you can say 1,3 diacetyl indole or you can say N3 diacetyl indole, which on aqueous which on hydrolysis with aqueous NaOH will give 3-acetyl indole. Ultimately at the third position only acidification will take place. Okay, that means this will generate acetic acid. Okay, this hydrolysis will generate acetic acid from here, 1H will be attached here, and ultimately you will get, or sodium salt of acetic acid will form. Okay, sodium acetate. So ultimately you will get 3-acetyl indole as a product. For this is the next electrophilic aromatic substitution reaction, that is Mannich reaction. So in Mannich reaction, indole reacts with mixture of formaldehyde and dimethyl ethylamine in acetic acid by substitution and converted into 3-dimethyl aminoethyl indole gramine. So this is 3-dimethyl aminoethyl indole, or it is also known as gramine. Okay, you remember. So here this is Mannich reaction. Formaldehyde will react with dimethylamine, in acidic condition it will convert to iminium ion. That iminium ion will react with indole in presence of acetic acid at room temperature to give 3-dimethyl. So this is the 3-dimethyl aminomethyl indole, or common name is gramine. So next, reduction reaction. So reduction means addition of hydrogen or removal of oxygen. So lithium in liquid ammonia or liquid ammonia reduce the benzene ring to 4,7 dihydroindole is the main product. So zinc HCl, we know it is a reducing agent, so it will form indolene, but liquid ammonia in ethanol, it will form which one? 4,7 dihydroindole is the main product. So two product will be formed. This one is another product. So among this 4,7, this is 4,7 dihydroindole. So it is present in 3 ratio and this is 1 ratio. So ultimately this 4,7 dihydroindole is the major product or main product. Next is nucleophilic substitution reaction. So you see N-butyl lithium in ether 5 degrees Celsius, so it will form lithium salt. Okay, here So two reaction may possible, nucleophilic substitution reaction. So here substitution is taking place. That means here react with carbon dioxide and then go for acid hydrolysis. So it will form carboxylic acid at the second position. Okay, it will attach one carboxylic acid group at the second position. But if you react with acid benzophenone and then you again do acid hydrolysis, H3O positive is acid hydrolysis, so diphenyl hydroxy compound will generate. Okay, so this is in the second position, diphenyl hydroxy will be attached. Okay, so from this group, so this is nucleophilic substitution reaction. So next let us see the medicinal uses. So you see indole, this is mainly available in the many various alkaloids. So as a indole alkaloid, reserpine, which is antihypertensive of the late 1950 early 90s to treat agitated psychotropic condition. Then it is also present in vinca alkaloid like vincristin, vinblastine as an anti-cancer agent. Then argometrin to prevent bleeding after childbirth. Okay, so smooth muscle constriction effect. So this is the structure of argometrin. Then argotamine, which is used in migraine. Next is a triptan, sumatriptan. These are drugs. All the triptans are used for migraine. Okay, you remember. So these are the drugs: sumatriptan, rizatriptan, nortriptan, zolmitriptan. So treatment of moderate to severe migraine and cluster headache because of their higher affinity and selectivity for the serotonin 5-HT 1B 1D receptor. So that is part of medicinal chemistry. Okay, so this sumatriptan and rizatriptan, see, this is containing the structure of indole. Then pindolol, so it is non-selective beta blockers. That means it will use to lower the hypertension or BP, mainly hypertension. It is used in the treatment of hypertension and angina pectoris. So this is the structure of pindolol. So here also you see this is the structure of indole. Okay, so basic structure, or it is a derivative of indole. So I hope you have understood. Thank you.